Hi, my name is Emily Van, and today I'll be discussing my topic on polymers, as well as issues revolving around bisphenol A and biodegradable polymers. So polymers are long-chain molecules comprised of repeating units of monomers covalently linked together. They are produced naturally and synthetically and can consist of one monomer or can be constructed by a combination of two or more monomers. In theory, synthetic polymers can be created from a variety of starting materials, but in practice the majority originate from crude oil or petroleum, albeit it is possible for plastics to come from renewable materials. Generally, polymers are resistant to chemicals, are great thermal and electrical insulators, are lightweight, and are able to offer varying degrees of strength. Due to their beneficial advantages, they are regularly found in consumer products. So addition polymerization and condensation polymerization are the two chemical mechanisms utilized to create polymers. In addition polymerization, monomers are sequentially attached to the growing polymer chain, and the resulting product contains all the atoms of the starting reactants. Polyethylene, which is solely composed of ethylene monomers, is an example of an addition polymer. To initiate this polymerization reaction, a free radical is required. The free radical will attack the double bond in ethylene and react with two of the four electrons present. One electron will move to form a bond with the free radical, and the other electron will move towards the end of the molecule as a way to produce a polymerization site at which another monomer can be added. The two residual electrons that remain form a carbon-carbon single bond. With this type of polymerization, no additional products are formed and no atoms are removed. Conversely, condensation polymerization involves the release of a small molecule during monomer linkage. In the case of PET, which is a copolymer of terephthalic acid and ethylene glycol, the OH of the carboxylic acid group and the H of the hydroxyl group will react to form water, which is then released. This allows for the two monomers to condense into one. The coefficient N specifies the number of monomers reacting and is adjusted during manufacturing process in order to generate specific properties for the polymer. Variances in physical properties also arise from branching within the polymer. This is why polymers made of the same substance can have different properties in different commercial applications. Bisphenol A, or BPA, is an important material that is heavily used in manufacturing polycarbonate plastics and epoxy resins due to its inflexible chemical structure, as it has two aromatic rings. BPA-based products confer rigidity, transparency, and high heat resistance, and is a main reason as to why they can be found in water bottles, food containers, dental sealants, and much more. Being a useful industrial chemical, BPA is one of the most highest volume materials produced worldwide. However, there are downsides with BPA in that it's a known endocrine disruptor that can leach out of the aforementioned products. As an endocrine disruptor, BPA affects the human hormone system by disturbing the normal functioning of hormones involved in the reproduction and sexual development. Particularly, BPA is characterized as a xenoestrogen that imitates the hormonal properties of estrogen and has been postulated to decrease testosterone and contribute to several mental illnesses and physiological disorders such as cancer and polycystic ovary syndrome. Exposure to BPA is a major concern to development of fetuses, infants, and children, but through the studies performed by the Government of Canada and the U.S. Food and Drug Administration, they demonstrated that BPA was not dangerous to human health at low to normal exposure. With that being said, people are strongly advised to limit their exposure to BPA as a precautionary principle. Countries like Canada have even established acts to ban the manufacturing, importing, and marketing of polycarbonate baby bottles made with BPA as a way to protect newborns and infants. It is truly difficult to pinpoint the adverse effects of BPA since it is unethical to test chemicals like BPA on humans. The only way to circumvent this restraint is to study those individuals who have been inadvertently exposed to BPA. Many safer alternatives have been looked into and developed for the purpose of replacing BPA. This includes, but is not limited to, BPS, BPF, BPAF, BPZ, BPP, BHPF, and diphenyl sulfone. Nonetheless, a vast amount of these analogous compounds have been discovered to interfere with egg and sperm production, as well as cause estrogen-related problems when studied with mice. Ultimately, BPA's products are useful and convenient, but since they impose a health risk to humans, more research must be done in order to conclude the adverse effects of BPA and BPA alternatives. Another prevalent issue with synthetic polymers and plastics is their disposal. The majority of plastic products are either found on landfills or waterways and are incinerated if not recyclable. Although most synthetic polymers are composed of petroleum and can be burned for fuel, the production of carbon dioxide that heavily contributes to pollution and the release of harmful gases are highly unfavorable and unsustainable. As a solution to the plastic waste dilemma, plant-based polymers have been devised from renewable resources such as starch, corn, wood, and cotton fibers. Biodegradable polymers are a unique class of these plant-based polymers and can be decomposed by microbes after their intended use. Upon degradation, they release natural byproducts such as biomass, water, and gases such as nitrogen gas and carbon dioxide. Accordingly, their synthesis normally requires fewer resources and uses less energy, in turn which results in less waste. One of the most well-known eco-friendly polymers is polylactic acid. Since it has a similar look and texture to PET, PLA is used as an alternative to manufacture some of the same products as PET. There are even studies reporting the use of PLA to engineer vascular tissue grafts for heart repair. Having said that, PLA and other biodegradable polymers lag behind in petroleum-based polymers in necessary properties such as high heat resistance. PLA also has its fair share of controversies regarding its synthesis from corn, such that the runoff from cornfields may contribute to eutrophication of waterways, and the corn utilized may be genetically modified to withstand pests. Although these biodegradable polymers have their flaws and their pros seem to outweigh them. Regarding their sustainable undertone, biodegradable polymers are a good alternative to petroleum-based polymers. Overall, synthetic polymers and plastics have been designed to serve society in ways unimaginable. However, with great abilities comes with great responsibilities in coping with health risk and plastic waste. With the cooperation and intelligence of policy planners, economics, manufacturers, and chemists, a new world of plastics and polymers may be created. For now, the best solution is to limit our use of polymers and recycle whenever possible. Thank you.